Hey guys, it's Miss Manili, and I'm just going to go over some of the problems from the review guide tonight. I'm not going to go through every problem because I feel like the first half is pretty self-explanatory once you see the answers. But I do want to just highlight on some of the last problems because they're going to be worth more points on the test, and I just want to make sure that you're answering completely and giving me everything I'm looking for. So I'm going to start with number 5. And in number 5, we're looking at a study of the effect of miscarriages on the health of subsequent children. The names of women who had had miscarriages were obtained from medical records in New York City hospitals. Birth records were then searched to locate all the women in this group who bore a child within 5 years of the miscarriage. And then hospital records were examined, again, for information about the health of the newborn child. So clearly, this is not an experiment. And on the test, you'll have like some situations where studies are for example, like the studies are wanting to be conducted and you're going to be asked like which is more appropriate, an observational study or an experiment, and then you'll have to say why. So if that was this question, if I was saying, you know, which would be better to do a experiment or an observational study, the answer would have to be observational study because the only way to perform an experiment would be to apply a treatment. In this case, the treatment would have to be a miscarriage, which would be completely unethical. So when you see questions like that on the test, you're going to want to make sure that you're explaining why. I mean, obviously, if we're trying to establish causation for something, then we're always going to want to do an experiment. But there are limits to what we can do, and it could be practicality, it could be ethical reasons, it could be financial reasons. So things like, you know, forcing teenagers to text and drive so that you can see the risks of texting and driving would obviously be unethical. Doing something with a simulation would be okay, but then we're probably losing the realism issue. If you remember when we talked about realism, having somebody do illicit drugs in an experiment would be unethical, but maybe having them, you know, have a couple beers as long as they're of drinking age would probably be okay. So you also want to look at things like the level of risk. And as long as the level of risk is minimal, then an experiment can usually be conducted. If it's a high-risk situation or if it's unethical, that's when an experiment would not be approved. So I just wanted to put that out there because the question there are some questions on the test that kind of ask which would be more appropriate, and you want to make sure that you're explicit in telling me why an experiment would not work if an experiment would work. So in this case, it's not an experiment. Obviously, we're not forcing these poor women to have miscarriages. We're just identifying them and looking at medical records. So this is an experiment. This is an observational study, but we want to make sure that we explain clearly why it's not an experiment, and that's because the treatment was not applied. It asks for the explanatory and response variables. The explanatory variable, and even though this is an observational study, we can still have an explanatory variable. We can still have levels and factors as well. In this case, we just have one factor, and it's the miscarriage, and the response then would be the health of the subsequent children. We don't know exactly what's being measured, but that would be our response variable. All right, number 6 is another study. It says to test the value of help sessions outside the classroom, students could be divided into 3 groups. One group receives 4 hours of help sessions per week outside the classroom. A second group receives 2 hours of help outside the classroom. And a third group receives no help. So the first thing you're asked to do is to identify the units. And so this is just basic vocabulary. Units, again, are the individuals or the participants in your experiment. And in this case, that would be the students. In letter B, it asks what are the explanatory and response variables. The explanatory variable in this case would be the number of hours of help sessions each week outside of class, and the response would be the value of those help sessions. And even though it's not stated, we can assume that it's going to be measured by some sort of test score or something. In letter C, what are the factors and their levels? Well, there's one factor, and that is the outside help session. And there are 3 levels to that factor. We can either have 0 hours per week, 2 hours per week, or 4 hours per week. And sometimes, like if we're using a placebo, that would kind of fall under the like if you're looking at levels of a medication, for example, then the placebo would just be like 0 milligrams, and that would be the lowest level. And number 7. It says, some medical researchers suspect that added calcium in the diet reduces blood pressure. You have available 40 men with high blood pressure who are willing to serve as subjects. So in part A, it says, explain in words how you will design an experiment to test this hypothesis against a placebo. So you're told you're going to be using a placebo in this case. Then it says to be sure to include all principles of experimental design. I think the best way to answer this question, and what makes it really easy for me to grade, is if you actually identify all 4 criteria. So you mention comparison and then tell me how comparison is going to fall into your design. Talk about randomization, talk about replication, talk about control, and that way it's very explicit. So in terms of comparison, if we're looking at the amount of calcium versus the placebo, it doesn't say anything about breaking it up into other levels. So I can assume that I'm just going to use 2 groups in this situation. One group will receive the calcium supplement, the other will receive a placebo. And what I'll do is I'll measure the blood pressure at the beginning of the study and then again after, let's say 12 weeks. It doesn't say how long, but any period of time will do. And then I'm going to compute the difference and compare. In terms of randomization, you're going to want to make sure that you explain how you're doing the randomization. On the test, there's actually a part where you're going to have to explain. You want to be very explicit. You want to act like you're giving instructions to somebody to do it for you. And so we'll want to label the men. If I'm using a table of random digits, I'm going to need to make sure the digits are the same length. If you're using a calculator, it doesn't matter. You can label them 1 to 40. But if you're using a table of random digits, they have to have the same number of digits. So I'm going to label them 0, 1 to 40. And then using the table of random digits, I'm going to observe 2 digits at a time. And I'm going to ignore repeats. And that's important in your instructions that you include that. And then basically, I'm going to select the first 20 men whose labels appear. And those are the ones that are going to take calcium. For replication, we know this condition is met as there will be 20 subjects in each group. In number 4, to control, we have a placebo that we're going to be used to control the natural response to the treatment. You might also want to include here that to reduce bias, it could be a double-blind experiment. The other thing that I didn't write is that one of the controls we're dealing with, we're only dealing with men, and we're only dealing with men that already have high blood pressure. So that is another measure of control. It's going to reduce the variability if I'm not dealing with men and women. I might also want to select men of a certain age group to limit the variability as well, and that's another form of control. So all of those things are fine. And you can express your answer in lots of different ways. But just make sure that you're hitting on all 4 of the principles of experimental design. In letter B, it says the names of the subjects appear below, and then you're asked to use the table of random digits starting at line 119 to do the randomization required by your design. And again, in this problem, you do have to be very explicit in how you're doing the randomization. I should be able to follow your instructions and get the same result. And in this case, you need to make sure that you label each of your subjects. Okay, and it doesn't matter how you label them. It's customary to number them in order, but you don't really have to. And it doesn't matter if you label them across or down. It doesn't really matter because you're going to be choosing their labels randomly anyway. But given the way I've labeled them, you can see from my table exactly what I did. You can see that I'm looking at 2 digits at a time. You can see that from the little vertical lines that I wrote. And then you can see, because I circled the labels that came up that were between 0, 1, and 40. And then I also circled them on my chart. So you can see exactly who the men were that were selected for my group. So I should be able to follow along and do the same thing. So even though you may number them differently, we should still get the same answers. Because there's a limited number of labels, I would be careful about trying to be too creative in your labeling. There's no need to label them with 3 digits, although you could, but you would run out of digits in the table if you did that. So you don't need to be creative. Just, label them, normally and select your numbers from the table and just make sure that it's clear how you did it. And then the last part of this question is to construct a diagram. And so in a diagram, remember on the left, we always want to start with our units, and you want to tell me how many there are and then any kind of unique characteristics about them. And in this case, we know they're men with high blood pressure. I'm indicating at the beginning of my study that I want to measure the blood pressure so that I have something to compare it to at the end. Then you want to indicate how you are assigning the men to groups. And so that's where I'm putting in the random assignment. If you were going to be using blocking or matching, you'd want to make sure that you indicated that as well. So it's important in this case, because this is a completely randomized design, that I indicate that this is the point at which I'm doing the randomization. And then in this middle part, and you don't have to separate them into two sections. I mean, it can be one big section where you have the group 1, which is the treatment group that's getting calcium every day, and there's 20 men in that group. And then group 2 is your control group, which gets the placebo every day, and there's also 20 men there. So you can communicate this in a different style, but this is essentially what you need to say in that middle section. And then the result, you need to make sure you're stating your response variable. And this would be the differences in the blood pressure after, and again, I just made up the 12 weeks. Because that's typically, if you're doing a medical study, it's usually, 12 weeks, 3 months, something like that. So that's why I chose that. But you can choose a different span of time, and that's fine. All right, at the last question deals with our inference issues, okay? And so you're given 4 different studies, and basically you're asked questions about what kind of inference can be drawn. So can we make inferences about the population or about cause and effect? Remember, with population, we need to make sure that we have a random sample from the population. We need to make sure our sample represents the population in order to make inferences about it. When it comes to cause and effect, that means that we're dealing with an experiment, and we have to use random assignment in an experiment. The only other thing to keep in mind with cause and effect is even if you do random assignment in an experiment, but you haven't controlled other variables, then you really don't get cause and effect. The only way to get cause and effect is if you have a well-designed experiment and you're using random assignment. If you have a really crappy experimental design, it doesn't matter if you use randomization. If all the other variables aren't controlled, you're not going to be able to draw conclusions about causation. So keep that in mind. It's not, I don't want to oversimplify it. All right, so in the first example, we're looking at volunteers at a gym that are randomly assigned to 2 exercise programs. Since they were volunteers, we know they weren't randomly selected, so we can't make inferences about the population, but because they were randomly assigned to the exercise programs, we could make inferences about cause and effect, assuming all of the other variables are controlled. In part B, a gym manager tracks the weight loss of members who regularly participate in the 2 different exercise programs and then compares the amounts after 8 weeks. Well, it doesn't tell us how they were put into the exercise program, so you don't want to assume that they were randomly placed in there. Also, we're not looking at a random sample of members, so we're not going to be able to have any kind of inference no matter what, not with the population, not with cause and effect. In letter C, a gym manager randomly selects 50 members who agree to be randomly assigned to one of 2 exercise programs. So this is like the best case scenario, but it's also not really practical. We don't usually see situations like this, but since we have random selection from the population, we'll be able to make inferences about the population. And since we have random assignment to the groups, we can also make inferences about cause and effect. And the last one, a gym manager randomly selects 50 local residents to participate in one of the 2 weight loss programs. The residents get to choose which programs to participate in. He tracks their weight loss in exchange for a free membership. So in this case, because he randomly selected the residents, he can make generalizations about the population, but he didn't randomly assign them to the programs, so he has no basis for cause and effect. So I hope that was thorough enough. I do want to just remind you to make sure that you know all your terms, things like blinding and double blinding. Just make sure you remember that that's when the researcher, if it's a single blind situation, it's either the researcher or the subject doesn't know which treatment they're getting, or if they're getting a treatment or the placebo. If it's double blind, that means neither the researcher nor the participant knows. Things like matching and blocking. Blocking, remember, is when you're expecting a difference in responses to a certain variable like gender or maybe size, color, grade, age. When there's a specific variable that you expect to kind of impact the results of your design or of your study, then sometimes it's a good idea to split the subjects up and then run 2 parallel experiments. So you're basically running, the randomized design that we used up here. Let's say I wanted to compare men and women. I would basically have this whole thing repeated for women, but there would be an extra section to the left that included like the 80 men and women, and then I would shoot them off into gender groups and make sure instead of saying random assignment, I would say block by gender, and then I would randomly assign them to the groups. I'm never mixing them, so I'm going to have 4 separate groups. I'm not going to put them in, I'm not going to randomly assign half the men and half the women to group 1 and half the men and half the women to group 2. That's not a block design. You want to make sure you're running parallel experiments. All right, so I hope that was helpful. Hope you guys have a good night. I look forward to seeing you tomorrow.